Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Isa Bramli. Today I will present about the assignment to be static scheduler with precise timer and Linux process. So first we will go to our code. We will have all the total of 5 code for master, task 1, task 2, task 3 and task 4. So for the master, we will see the hashtag include and the define of all the hashtag include, and we go to the timer get timer ID. This is start timer value. So we can see the timer timer ID used to create timer with the callback function. So we can see the clock monotonic represent the absolute elapsed wall clock time since some arbitrary fixed point in the past. It is then affected by changes in the system time of the day clock. So we can see the code my sign alarm handler. It uses to monitor alarm conditions of EPIX database record, and we can see this is the schedule in the table, schedule time. We can see all. So this is the condition. We can see the condition. If PID equal to 0, it will go to switch mode. Switch case are task 1 break, task 2 break, and so on. Case 4, the case 3 and case 4 will you also exact. So for the timer create and the timer set time function is to precise period of execution in the task. So we can see like same as master, we have also timer get timer ID, start timer spec value. This is place where we converted from the time to the nanosecond. So same alarm handler, start time spec begin and for elapsed time. In this lab, the function of fork exact timer create and timer set time will apply. Also fork function also will apply. System call fork is used to duplicate or create a new process. After a new child process is created, both processes will run the next task following the fork system call exec. System call exec is used to execute a file which residing in an active process. Task is replaced with new task. For timer create used to create new per process interval timers. New timer returned by timer ID. Timer set time used to arm or disarm the timer identified by timer ID. The new value argument is a pointer to an item spec structure. For this the task. For the task, it also same. Task 1, task 2, task 3, task 4 is different at the operation, addition, subtraction, multiplication and division. So these are different and the place is different. They also use struct function and same. So we will compile by using the terminal. CD desktop master, and we will see the output of the master that we have combined task 1, task 2, task 3 and task 4. And we can see it will follow the schedule. Task 1 +3 +2, and will ideal, and we can see the operation and the output of the operation and the total time in a second, and capture time signal 14 and time. It will repeat based on the table in the lab 2B. So the task is going on, and it still will be repeat the task as same. So the final for the discussion, what is lacking in the solution? The value task in the table of the lab 2B is slightly different with our output. This occurs because of using table to manage timers. It has the following problems. Since the table is static, only a finite number of timers are allowed. Each time through the timer ISR, the timer table must be scanned. As the timer table is increased in size, the time spent in the time ISR increase, which adds overhead to the system. This problem can be overcome by using a queue differential timer management scheme. So this is the discussion for the task in the lab 2B. Before I forgot, for the capture timer, it used to start the process flows when a certain amount of time has passed without the user task or sub-process having completed. So that's all from me. Thank you.